So I updated the training CTF with a lot more challenges. So right now, these are the cryptography challenges, forensics challenges. This is what we're going to be talking about today, how to do all these. Then there's Linux and scripting ones, which we've already been over. There's networking ones and steganography ones, which we're going to go over those. And then there's trivia ones, which I added as well. And those you can just like Google. An example would be, what is the standard secure size of an SSL certificate? You can Google that. So this is what we're going to be basing all our training off of. Okay, news in the past week, cybersecurity news. The only big thing that happened was Bad Rabbit ransomware. It's affecting Russia and the Ukraine right now. It pretends to be an Adobe Flash installer, which is different from other ransomware that has massively affected Russia and the Ukraine, like WannaCry or PETA, because those two use the Eternal Blue NSA exploit to spread and gain access to everybody, but this one's just posing as an Adobe Flash installer. And it's pretty bad. It wipes all logs, and it even wipes USN Journal, which we're going to talk about today. So upcoming CTFs, we've got HitCon CTF qualification round. That's November 3rd, 10 p.m. to November 5th at 10 p.m. We don't have any competitions this week or any sooner than that. That's the only one. It's online, and then if we make it past the qualification round, then there's finals in Taiwan, and they reimburse us for travel expenses. So that's cool, but a lot of professional teams also compete in this, so it's unlikely that we'll get to that point. So today we're going to be talking about forensics, and the community around forensics is called DFIR, Digital Forensics and Incident Response. And you may have heard of that, maybe not, but that's what it's referred to as. Some examples of companies that use forensics are data recovery companies. So if if your computer breaks and you had really precious photos on them, or they're confidential information, or something that you really need to get back, you can hire a data recovery company to try to figure out what they can get. Oh. You can hire a data recovery company to figure out what they can get off of that computer. And most of the time they can recover a lot. There's also law enforcement. So if there were crimes that were committed with a computer, or like hacking, or child porn, those are the two biggest ones. Or if there were in-person crimes like homicide that were planned with a computer, like through emails or texts or things like that are stored on a computer, law enforcement uses digital forensics techniques to prove that someone did it and gather evidence. There's also, related to that, there's expert witnesses. So if you know a lot about forensics, you might be called in to be an expert witness. But you have to know a lot to get to that level. There's also incident response. So within companies, incident response, that could be like a SOC, a Security Operations Center, or a CERT, a Computer Emergency Response Team, where you're just monitoring what's happening inside the company and looking for things that are off or attacks, and then responding to them as you see fit. So that could be running something like Snort, if you've heard of that. That's an IDS, an intrusion detection system. And what that does is it captures all the traffic on the network, and it establishes a baseline, a pattern of what is normal. And then if something else happens that's not normal, it flags it. And you can set custom flags, and you can get into deeper detail. But that's an example of what happens if you're on those teams. There's also normal incident response, which is not part of internal. It's external incident response. So let's say a company gets hacked, they get ransomware, or a university gets ransomware. They're going to need help in seeing if they can do data recovery and restore all that data, if they need to pay the ransom, or if they shouldn't pay the ransom, and they go to other companies to do that. And that's one of the companies that I work at. So host-based forensics. So there's different types of forensics, first of all. There's network forensics, which is like the SOC and the CERT, where you're just monitoring the network and you're capturing data, and then you can look at past data in PCAPs, and you can try to figure out what happened. And then there's host-based forensics, which is you're looking at computers, and you're trying to figure out, okay, what are the artifacts in the computers that can tell me about what happened earlier? And then there's mobile forensics, which is like phones. So an example of host-based forensics, one of the interesting things about that is you can't modify the evidence if you want it to be used in court. So people use what's called a write blocker. It's a piece of hardware that only allows you to read data. It doesn't allow you to write data, so you can't physically change anything on the computer. And then you use that to make an image, so a copy of the computer, and then you go through the image and try to do your analysis there. So that way your evidence can still be used in court. And that's what's called forensically sound, is doing things correctly like that. One of the important artifacts is the master file table. If you go into the root directory of your computer, it's $MFT. You might not be able to see it depending on your permissions. That's in Windows. But that is a list of all their files on the computer and their metadata. So like there's 6 timestamps in the MFT, so it's depending on when they're modified, when they were created, when they're everything like that. Then there's event logs. That's one of the first things that you look at in incident response if you're on a host, because a lot of times, at least at my work, when you get ransomware, it's because someone brute forced RDP, because someone had a weak password and they left their computer internet facing. So what actually happens is there's these scripts that go around the internet, and they try to brute force any open-facing RDP with like the top 500 passwords or whatever in RockU. And then if they get in, then they install this exe on the system that allows concurrent RDP connections. And then they list the credentials on this Russian website called Xstatic. And so you have to buy into Xstatic, the marketplace, and then you can buy people's credentials. So you buy all the credentials for, let's say, $6 a piece for an entire company. Then you log in and you make sure, okay, I figured out this company's on the West Coast, so I'm going to wait till it's 3 a.m. there. Then you're going to log in, and then you're going to run some ransomware that you bought from someone else on the darknet. And then the ransomware encrypts all their data, and it says, okay, pay 28 Bitcoin, and I'll give you all your data back. Here's how you get Bitcoin. That's a common scenario. So if you want to figure out if that happened, you would check the event logs, specifically the terminal services operational event log. And that would show you the RDP connections. And if you saw RDP connections from a Tor node or like a web proxy or any suspicious IP that's not in the US, so if it's connected from like Romania, that's probably a bad one. Then there's browser history. So that's obvious. If someone's browsing to places that they shouldn't be browsing to, that could be a point of compromise or evidence of compromise. Then there's the shim cache. So there's a bunch of ones, but I'm just going over the most important ones. The shim cache is a ton of data. It was originally introduced in, I think, XP to track compatibility issues with executed programs. So it actually has a list, because of that, of the executed programs and any programs that you've browsed to. So if you open up a folder and there's an exe or a DLL into it, it'll add that to shim cache and have some data about that. So that's because if an attacker is doing something malicious, odds are they've run some bad form of exe or DLL in order to do something malicious to your computer. So that's a really good source of that. Shim cache is also called appcompat because it's in the application compatibility folder. And then there's parsers. So a lot of these artifacts, for example, the MFT or the shim cache, and even some event logs, are not easily readable by humans. It's just machine data. So you have to have parsers in order to convert it to TXT or something that humans could read, or XML or JSON. So that's an important part of host-based forensics. And all of those, there's a bunch of parsers that are open source. So forensics and CTFs, there's the simplest challenge, which is solvable by strings. The strings command outputs all the printable characters in a file. So it's not really forensics, but it's a lot of times placed in the really easy challenges in forensics and CTFs. It's also sometimes in the easier reverse engineering challenges. So all you have to do is, if someone gives you an exe, or they give you a weird file, or they give you an ELF, you just run the command strings on it if you're on Linux or Unix, and you'll be able to see flag. And if there's too many characters, you can just do the pipe character and then grep for flag, as we've done before in that works pretty well. There's network forensics and steganography. Network forensics you're going to want to use Wireshark for. We'll go over that, I think, next week. And steganography, there's a bunch of different tools you can use for it. That's when, and it's usually in CTFs, it's data hidden in an image. But in general, it's when you hide data or a message in a way that it doesn't look like there's any hidden data there. So in cryptography, there's a jumbled bunch of letters or numbers, or there's something, you know it's a message, but you don't know what the message is. In steganography, you don't even know that the hidden message is there in the first place. So it could be a picture of a stegosaurus, and you don't know that there's a flag inside the picture. Then there's broken file formats. So a lot of times it's PNGs, sometimes it's other ones. In general, in forensics, you're going to want to become familiar with the different types of file formats and how to change them and how to fix them if they become corrupted, because that's pretty common, and that's common in forensics in the real world and data recovery. So we'll go over that. And then there's disk or VM images. So if you give someone a .img or a .raw of a disk or a virtual machine, and then you hid flag.txt, which contains the flag, in a random folder, you're just going to want them to mount the image, so be able to view what's inside it, and then dig around, and it's a needle in a haystack sort of thing. So it just takes time. Also, if it's, they might make it in a tricky format where like the .img or the image itself might be corrupted, so you have to fix that or mount it in a weird way, and then it'll be easier to find usually. So strings, it outputs the printable characters in a file. That's just an example of my command prompt. I was in the folder Sharknado, that's not part of the command. So I did strings, file.pcap. You can run it on pcaps, you can run it on ELFs, you can run it on a bunch of files. And then the pipe character, which means it's searching for the word flag, and .-i means any case, in file.pcap. So that's an example. That's how you solve one of the challenges that we'll do today. And even if that doesn't solve it, in PCAPs, it could give you a hint, like, it could give you a hint, if it's flag.png, or it's a photo of a flag, you won't be able to read what the flag is with strings, because it's not printable characters. But you will be able to see what messages it's in, what packets it is in, and that it is a PNG, so then you can just search for a PNG. Another example of forensics is looking through the EXIF data. So the EXIF stands for Exchangeable Image File Format. It's metadata about a photo, basically. Or not necessarily a photo, it could be a docx, it could be any file. But it says the size, it says the author, and it says the timestamps, the geotags, the encoding, and the resolution, if it's a photo, or whatever applies out of those. So the most important ones out of those are author and geotag. Sometimes the author will be the flag. Sometimes the author will be hex data that you can copy and paste into a hex editor, and it'll be a picture, and that picture will contain the flag. And then there's geotags, so that just is coordinates. And if someone ever asks, like, where is this picture taken? You can look at the EXIF data, and if it stores the coordinates in there, which a lot of phones or cameras do by default, it'll have that there. I remember one time, I think it was in 2 years ago, some ISIS fighter posted a picture on Twitter, and it contained the geotag coordinates of his location. So the U.S. just immediately bombed his location. So it is useful in the real world. In order to view EXIF data, there's online tools. You can just Google EXIF online viewer, and there'll be a bunch that come up. Or you can use EXIF tool specifically. That's the best one. That's the one I use. If you don't have EXIF tool and you don't want to download it and make it work on your computer, then you can go to our Mason CC virtual machine. That contains it by default. All right, so here's how you solve a corrupted PNG, because that's one of the more common formats that you'll need to uncorrupt. So in the regular PNG format, there's a header. It's called the magic number 8950. And that header, 8950, 4047, that is in hex the translation of .png. That's what starts. So in a normal PNG, it's made up of, after the header, chunks. So the chunks work like this. There's the length, which specifies the length of the chunk. It's 32 bits. Then there's the chunk type. So there's different kinds of chunk types in PNGs, but the first one, for example, is IHDR. And then there's the chunk data, which is length bits. So if length is 32 bits, then the chunk data is going to be 32 bits. If the length is says it's going to be 64 bits, then the chunk data is going to be 64 bits long. Then there's the CRC, which is the cyclical redundancy checksum, which is also 32 bits, and that's just to make sure that all the data is correct and unmodified. Or if the length is 0, then there is no chunk data, so it's just length, chunk type, and cyclical redundancy check. So one of the examples of if things go wrong, is if the cyclical redundancy checksum is off, then there's tools that will enable you to fix that and automatically calculate it again. But the simplest version is it's actually a JPEG and they just named it PNG, but they didn't convert anything. So in that case, if you run the file command on it, the file command doesn't count the name of the file. It just analyzes the format of the file. That's in Unix, it's in Linux. So if you run file space example.png, it'll give you that it is a PNG or that it's actually a JPEG in PNG format. So if it's the wrong format, you just change the extension and you open it and it works. If there's a missing or corrupted header, so like I went over that magic number and that header, that has to be there. If that's on there and you try to double click the PNG, it won't open, it's corrupted. So if it's messed up or it's not there, you need to add it or fix it. And it's always the same. And you can do that with a hex editor. So you can do PNGs or any file in hex. And you would just copy the 8950, whatever that is, and paste it into the beginning of the file if it's missing the header. Then the third one is the incorrect CRCs. So if the checksum is wrong, but everything else in the file is good, you can just run PNG csum, and that will run the checksums again, and it will correct it automatically. That's a tool you can download. It works well. So today we're going to be doing practical challenges again. So if you go to go.gmu.edu/tctf or that IP, I added a bunch of new challenges. I added another cryptography challenges. I added steganography challenges. I added networking challenges. Today we're going to focus on forensics, but if you haven't been here or you're having trouble with any of them, you can just go back to those. Or if you want to work ahead on the networking or steganography or trivia or anything else that you see that you find interesting, go ahead, I'll help you out. Looks like this. If you don't have an account, sign up. The new ones are Intro to OTP in cryptography. So it's 2 photos, and it says the original message was XORed with the key to produce the ciphertext. And the one time pad is symmetrical, so that should give you the hint on what you need to do in order to fix that. I would recommend StegSolve, even though this is not a steganography challenge. That's a way to solve this one. And there's the trivia ones, which you can Google. Networking ones, which is we will teach. You need Wireshark, steganography, but today we're going to be working on forensics. The first one is called Sharknado. So you got to think about what we went over and what could you apply to this. So you can just run strings on the file. If it's a PCAP or if it's something like this, that might help you. Writer. So who created this masterpiece? You got to figure out who's the writer, the author, the producer of this file with the techniques that we discussed today. There's Bigfoot, which is just picture, and you got to find where the picture was taken, which city the picture was taken near. And there's corrupted, so it's a corrupted PNG. We went over the different ways to do that. It's either the header, or it's the wrong extension, or it's a CRC problem. And then there's a image.